Okay guys, in this episode we will look at the LeetCode problem number 3, which is the longest substring without repeating characters. So let's quickly look at it with help of some examples. Suppose you have been given a string as an input, which is ABC, ABC, BB. So in this string, let me just quickly write it. You have to find out the longest substring. So substring is any string which is, which can be like, part of this string without repeating characters. That particular substring should not have any characters which are repeating. So in this case, example, right, the longest substring which we can find without repeating character is, ABC is there, right? Let's look at, can we form anything which is bigger than 3? ABC, BCA is another, but it is again 3 characters, BCA. BCB cannot happen because then BCBB will be repeating over here. CBB cannot happen, right? CAB can happen, right? So when we look at all the possible options, we do not see anything which is more than size 3. So the response has to be 3, right? That is the problem. Right? Let's look at another example. This is the other example. Right? In this case, you cannot form any substring with more than size 1, which is the B character, right? With non-repeating characters. So the answer over here is 1. Right? Let's look at another example. PWW, KEW. In this one, what will be the answer? See, PWW cannot be there. WWK cannot be there. I can see WKE, right? WKE is there. KEW can be there, right? I cannot add W over here because then it will be repeating. And similarly, I cannot add W over here because then it will be repeating. So here also the answer is 3, right? So we quickly looked at all the possible, examples, right? Now let's look at the solutions. So let's first look at the brute force algorithm, right? So brute force algorithm is extremely simple, right? We can just figure out all the possible, substrings. So, if we can look at the string and figure out all the possible substring. What is a possible substring? Empty string is a possible substring. This is a possible string. This is a possible string. This is a possible string, substring, sorry. And so on, right? All with length 1, right? This is length 0. Then we can go AB, BC, and so on with all size 2. And similarly, we'll find with size 3, size 4, and so on, basically. And if we have this list of all the substrings, right, we can just iterate over all these substrings and just figure out which ones have the biggest length with non-repeating characters, right? So like for instance, this one is non-repeating, this one is non-repeating, these are all good, these are all good. But probably if you're going to do that, probably it is wiser to go from here onwards, because so if you're able to find a substring that's say size 7 or size 6, then you can stop there. You don't have to check over here because then these will be smaller substrings, right? Anyway, so you can find your answer over here, right? And that probably will be the brute force algorithm. Order of this algorithm would be order of n square, because there will be roughly n square strings which you can form by iterating over all the possible substrings. And that is the brute force algorithm. And I think that should be fairly easy to understand. Now, let's go to the next step. Okay, so now let's look at the optimal solution. So, let's start with this sample, right? A, B, C, A, B, C, B, B. Okay, so when we are looking at the sample, this example, right? Let's start from here. Like, how will we do it basically? So let's start with here. Let's put a pointer over here, and let's say our string starts from here, and we put another pointer which is the end of this substring basically. So suppose our string right now, the string which we are considering is just this single character A. Now, if A, and let's say we keep track of the max length of the substring which we have found up till now. To begin with, we can reinitialize max length as 0. So now when we start looking at just this string as the substring, Is there any repeating character in this? No. So now our current string which we have figured out, the substring which we have figured out, is actually A, and the length has become 1. So we can just keep track of it, saying 1, right? Now let's advance our pointer. Let's assume that we can include. Let's check whether we can include our the next character into our string or not. Then our substring becomes AB. Is anything repeating in this? No. So now our answer becomes 2. Maximum length is 2. Now let's advance it further, right? C. So now our substring becomes ABC, right? Anything repeating in this? No. So great. Our max length becomes 3. Now let's advance it to the next character. Now our substring becomes ABCA. Is there anything repeating in this? Yes. This is repeating, right? And now we cannot further increment this, or we cannot put max length as 4 because this is not a valid substring. So this is an invalid substring according to the given condition, right? So now what do we do? So what we have to do is we have to continue looking for other characters, other substrings, right? So what we have to do is, if we want to figure out the next substring, what we can do is we can eliminate this A, right? And then because this 4 size is causing it to become repeating characters, we can eliminate this character and our substring now becomes BCA, right? And that's great, right? Now we can continue, right? So suppose now, what is the max length with this substring? It's still 3, right? Now let's move this to, and so once we have removed this, our pointer has moved to B now, right? Starting point. Now let's add B over here. Is this the a longer substring? No, because then again B is repeating. So we do the same thing. We get rid of this B. So we have moved our starting pointer further. So starting pointer becomes here and becomes cap, right? So our new, and what is the max length? Is still 3. So nothing to update over here. And then we add C. Our pointer was here. We move it to here. And again the same thing happens, right? And so on, basically. So if you continue with this, you will figure out that the max length is 3 actually. That is one thing. Now let's look at another thing. Watch, other possible sample, right? Another possible example. So let's make it a bit more complicated. So A, B, C, right? Now here A was repeating earlier, right? So we are not looking at this one, we are looking at a new one. Here A was repeating earlier. Let's repeat B over here instead of A, right? A, B, C, B, right? And then let's see how it works. So A, B, C, B, B, C, B, B, right? And the answer of this one is also still 3 because the longest substring is ABC, right? Now let's see how it works out. So we put our starting pointer over here, and then our next pointer is also at A. So our substring becomes A, max length initialized to 0, right? Now A is our non-repeating substring, so max length becomes 1. Cool. Now we move this pointer to the next one, right? Now the max string, so the next substring becomes AB. No repeating characters, great. 2. Move next. C. No repeating characters, great. 3, right? Then we add B. Now it is repeating, right? Remember, our starting point is at A and our current pointer is at B, right? Now, what we have to do, we have to shorten our string, But remember, our starting pointer is at A, right? If we move our starting pointer to here, right? So we remove A. Have we solved the problem? No, it is still not a valid string. It is still an invalid string because there are repeating characters in this. So what we have to do is we have to further move. So we have to continue moving until we again have a substring which is valid, right? So our now substring becomes CB, and this is a valid string basically, substring which has no repeating characters. But the max length, or the length of this substring is 2, and hence we don't need to update this because we've already found a bigger substring of that, and so on. And we continue with B, right? And then we move our starting pointer here. Still, remove this, basically not a problem, not solved, still invalid, move further. So we remove this B and so on, right? And if you continue down this path, you'll figure out that this is the maximum substring, and the maximum length was 3, which we found earlier, right? So this is algorithm number 2, you can say, which is like which is optimal solution. And the good thing in this is that the order of this problem, this solution, is going to be order n, basically, because we are pretty much iterating on this n times, and maybe in some cases we are iterating the first pointer also, but then that iteration will not be more than 2, and total iteration will not be more than 2, which is order n, basically. So great, right? Now, how will we write it in actually in code? The way to write this in code would be, how do you keep track of repeating characters? So let's quickly, let me just rub it and show you exactly how you'll write it in code. So coding part is very simple, right? What we will do is, the intuition is clear, how we will solve this problem. What we'll do is, we'll obviously put 2 pointers, I and j, both pointing to starting pointers, and initialize max length as 0, right? And then what we will do is, we'll keep a hash. So let's denote our hash with the empty square, right? And initially there's nothing in it, right? And when we first form our first substring, we put a. So we've got an a. We will just put a into the hash set, right? And then we increment to b, so our j increments to b. Now j is over here, so j, right? And then what we do is, as soon as we increment this over here, at the time of incrementation, we check whether b already exists in the hash, because this hash actually contains all the characters which are seen in the substring, already. Now b already does not exist, so we are good, right? So it is a valid substring, right? So we add b to it, right? And at this point in time, we move to the substring ABC. While adding C to it, we check whether C exists in this. No, C doesn't exist. It's an order 1 operation, because just checking inside hash, right? And so we add C, and max length becomes 3 now. Sorry, so I forgot to 1, 2, 3. So max length becomes 3 now, right? And so on. So we use hash to actually implement this algorithm, right? And then once in the fourth case, let's look at the fourth character also. Once we start adding A over here, we check whether A actually exists already. That is when what we do is, we start moving I. I was here, right? J has reached here. We start moving I, and when we start moving I, we start deleting these characters. So we move I from here to here and remove A. Is it a valid string now? Because this thing, does it still exist? So A is gone. Does this A already exist? No, it doesn't exist. So great. So we found another string, add A over here, basically, right? And so on. So using hashes, we can write this algorithm. And the only thing in this algorithm to understand is, let me just explain that by another example. So suppose you have this A, B, C, D, E, F, G, H. Now suppose you find another G. Let's look at this example, right? In this example, what is the longest substring without repeating characters? That would be this, A, B, C, D, E, F, G, H. Because as soon as G enters, it becomes a repeating substring, right? Now, let's add few more, say X, Y, and Z. Suppose we wanted to check out these fit. So how we'll go about it? We'll start from here, both the pointers, and then slowly increase. There will come a point when this pointer will reach up to here, right? And at this point in time, in our hash, so I'm just building another hash for this. So we would have A, B, C, D, E, F, and G, and H. We have all these characters up till now, right? And now, once we move this pointer over here, we figure out, is G exist? Yes, G exists. Now what we have to do is, we have to start moving this pointer until we again have a valid substring. So if we move this pointer over here, so once we have moved over here, we remove this A. Remove A. Is it still invalid? Yes, because G is still repeating in this substring, because G exists. So we further move this and remove B. Still invalid? Yes, it is still invalid. So we further move this. C gone. Is this still invalid? Yes, it's still invalid. So we further move this. So this is how the algorithm works, right? Eventually, what would happen is even up till here the string will be invalid, and then finally when you move, and all these things will be gone, and finally when you have moved the pointer to here, and this would be gone, and you would have been left only with h over here, is the point where you figure out, oh, now it is actually valid, and that's when you add g and start your algorithm again. And then eventually, if you go here up till here, you will find this is also another substring without repeating characters, but the longest which you have found was this, which is 7 characters basically. This is 5 characters, so the answer will be 7 basically, right? There's one inefficiency, slight inefficiency in this problem, which in this solution, and we can probably try and solve that inefficiency. So let me explain how we can solve that inefficiency in this. See, ideal case scenario, when you're looking at this example, right? When you put your pointer over here and you slowly advance your other pointer, right? Slowly increasing the size of the substring. So you got your substring up till here, A, B, C, D, E, F, G, and H. You figured out up to this point. Now, when you add G, right? And you figure out, hey, this is not a valid substring anymore. And your starting pointer was here. The current pointer was here. How about if you could immediately jump your starting pointer over here? Wouldn't that be nice? Because then you won't have to iterate your pointer from here to here. How you can do that? Very simple thing, So hashes, right? Hashes, the way we used hashes over here and even the previous run, we used hashes as a set basically, where we just added things which existed in the substring already. Another way we can use hashes as key value pairs. Key value pairs. So when you use hashes as key value pair, what we can do is, so let's start again from here, right? In this case, when we start over here, our max length is 0 at this point in time, say for instance, right? And we have both our I and j pointing over here, right? At this point in time, our substring which we have found up till now is A, right? What we do is we put A as the key and the value as the index of this character as 0, for instance, right? Now what we do is this it's a single character, right? So no repetition. So this is the longest substring which we have found up till now. So maximum becomes 1, right? And then we advance our pointer j over here. Now when j is here, our substring becomes AB, and we check, is B already exist in this? B doesn't exist. B is not a key in hash, right? Great. So our longest substring becomes AB, and our size becomes 2 now, right? Now when our size becomes 2, what we do is we put B, we add B into the hash, put B as the key and the index 1 as the value of it, and now we move our pointer j over here. When you put j over here, C gets added to the substring. Is C exist in this? C doesn't exist in this. And this, so C 2, this becomes 3, and along substrings like that. And then when you continue, so you'll have D, E, F, G, H. So D will be 3, E will be 4, F will be 5, G will be 6, and H will be 7, right? That will be the state of hash once you have figured out up till here. Now our J is here basically, right? Now let's move our J over next. As soon as we move our J over here, G gets added, and we first check, is G exist in the system? Yes, it does, and this makes our substring invalid. The moment our substring becomes invalid, how we advance this pointer from here directly to here, you can see, right? What we do is, this is the character which is repeating. We go inside the hash, right, and check the index of this character. So the index of this character is 6. What we do, we put I equals to the hash, the key, G, and what we'll get, this value of this thing will be 6 and plus 1. The moment we do that, immediately our I jumps from here directly to here. instead of iterating one after the other. And so our I over here, and then we can just continue algorithm like that. And that's a slight modification which makes it even more efficient, and now it becomes purely order n basically, right? I hope that clears up this particular problem. It's a very interesting problem, a longest substring without repeating characters. And be sure to check for all the boundary conditions, like when you have just one character. Also check for empty string to be being passed, and so on. Thank you.